Ah, this is the one. I know you waited for this one. Oh, my friend, I got something to say for you. Ah, need a big tank. I'm thinking you need a big tank. I'm thinking we need a big tank. I'm thinking.
Okay, today to test out my new slow motion camera I got, I'm going to be dropping a feather and a chunk of metal and see if they hit the ground at the same time under a vacuum. So the key to this experiment is dropping them at the same time. So what I'm going to do is I'm going to attach the feather to the top of the vacuum chamber with a magnet. So this experiment proves that gravity pulls on everything with the same acceleration. And the reason is because the force that gravity pulls down on you is proportional to the amount of mass in the object. So the more mass an object has, the harder gravity pulls on it, but the more mass it has, the harder it is to move. So what that amounts to is everything is pulled down at the same acceleration due to gravity. But what makes it a little bit messy is that in air, there's also air resistance when things fall, and so you can't really see how everything falls at the same rate. But if you remove that air, then you should be able to see that effect. Okay, first we'll do in-air test. So this is dropping a feather in air. Okay, we're under full vacuum now, so let's do our test under vacuum and see if it looks any different. Okay, I want to do it in normal speed so you can appreciate how fast the feather actually falls. So here's feather in a vacuum, normal speed. 3, 2, 1. Looks like it almost gets pushed down. It's weird to see it fall like that.
Okay, I want to do it in normal speed so you can appreciate how fast the feather actually falls. So here's feather in a vacuum, normal speed. 3, 2, 1.
But what makes it a little bit messy is that in air, there's also air resistance when things fall, and so you can't really see how everything falls at the same rate. But if you remove that air, then you should be able to see that effect. There's also air resistance when things fall, and so you can't really see how everything falls at the same rate. But if you remove that air, then you should be able to see that effect. Okay, we're under full vacuum now, so let's do our test under vacuum and see if it looks any different. Hey everyone, thanks for watching another episode. If you like this video but you haven't yet subscribed, remember to hit that subscribe button so you can be right on the ball, see the next video right when it comes out.
Okay, we dropped 2 Millitor in the last 30 minutes. But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCV 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly. They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down. Gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the Earth. So he concluded they weren't.